welcome students. In today's video, we're going to take a look at how to solve single-step algebra equations, specifically those involving multiplication and division. Before we get started though, what did the buffalo say at the school drop-off? Oh, he said, "Bye, son." What is it? It's like bison, but bye, son. No, bison, buffalo. Nothing? Okay. All right, let me first start by moving this over here. Sorry about that. All right. It says for our first example here to create a tape diagram to model and solve 3z equals 9. So first of all, when we think about an equation, right, an equation has an equal sign. It means both sides are the same. So what this is saying is that 3z is the same as 9. They have the same value, right? They're equal. So I'm going to write that same value. Okay, so when we think about that those are equal, I'm going to start by drawing two boxes, one that represents 3z and one that represents 9. And they're both going to be the same because, again, 3z is equal to 9. So I'm just going to draw one box here. And then the other one is going to be the exact same thing. And if I look at them, they almost kind of look like an equal sign, actually. Okay, so one is going to be 3z. So I don't know, I'll call that the bottom one. Doesn't really matter which one's which, but we'll call that one 3z. And then the top one we'll call 9. Okay, so they're the same, right? One is worth 3z, one is worth 9, but they have the same value. Well, my goal is to figure out what one of the z's is worth, right? How much is z? What is the value of z? Well, this bottom tape diagram represents 3 z's. So if I split this into 3 sections, each one is z, and I go, wait a minute, hold on. I know that if I take the 9 and split it into 3 sections, so first of all, the 3z, each one of these is worth z, right? There's 3 z's there. Well, if I do the same thing to 9 and I split that into 3 sections, each one is worth 3. So when I look at that, I can see obviously z is equal to 3. All right, now, obviously with this one, you're probably looking at it, you go, well, obviously z is 3. I mean, we can see that from the problem, right? It's 3 times z is 9. Well, z has to be 3. That's fine, but I want you to see conceptually how we can look at this, right? All right, let's take a look at number 2. Looking at the same problem, right? But now we're going to look at how to solve this using, we call it solving algebraically, all right? Basically solving using inverse operations. So again, we obviously know that the answer is 3, right? But the process here is what we're looking at. How can we develop our skills for solving these on ones that are relatively straightforward? That way when we get to more challenging ones, we can succeed. Okay, so when we look at this, I'm going to follow the same set of steps I did for addition and subtraction equations, which is I'm going to start by splitting my equal sign down the middle, splitting my equation into 2 sides. As you get better at this, you won't have to do the dotted line, but I highly recommend it for now. We're always going to start on the side with the variable. So I'm going to start on this left side because that side has the variable on it, right? And I can see the variable is right here, right? That z is my variable. Okay, so the question is, what operation falls between the 3 and the z? Well, remember, the 3 is what we call a coefficient. So that 3 is called a coefficient. And it is being multiplied by the variable, right? So 3z is the same thing as saying 3 times z. Well, in order to undo multiplication, what I need to do is division. I'm going to do the inverse of whatever's happening on that side of the variable in order to work backwards and figure out what the value of the variable is, right? Because my goal here is to isolate the variable, to have it be z equals. So if I divide this by 3, now I have 3 divided by 3, which is 1. right? 3 divided by 3 gives me 1. So all I have left on that left side of the equation is the z, or 1z. Well, I can't just do that to one side, right? What I do to one side of an equation, I have to do to the other in order to keep it balanced. So I also have to divide 9 by 3. Well, 9 divided by 3 gives me 3. Okay, now, again, we found the same answer for both, right? That z was 3. But my process of algebraically solving this is really important to understand. All right, now I'm just going to substitute the value 3 back in for z and see if it turns out to be true. So 3, and now instead of z, I'm going to substitute in the 3. And does that equal 9? Well, 3 times 3 is 9. 9 equals 9, so I'm good. All right, so when we're looking at a multiplication, algebraic equation involving multiplication, we're going to divide, which is the inverse of multiplication, which allows us to undo that multiplication and work towards isolating the variable. All right, now let's take a look at number 3. So this one, we're doing the same thing, right? We're creating a tape diagram to represent and model and solve this equation. It's going to be really similar. These y divided by 2, remember a fraction is a division problem, right? We say that all the time. A fraction is a division problem. A fraction is a division problem. So we see y divided by 2 equals 4. So I'm going to draw my 2 boxes to represent my tape diagram here. So I got one box here. I got one box here. Okay. So, and actually for this one you could probably just draw one box, but anyway. If I'm going to call this one y, right, this is my whole thing. My whole box is y here. Now, if I divide that by 2, right, that means I'm going to be splitting it in half, right? And if I look, after I divide it by 2, right, what is it equal to? Well, 4, right? Because y divided by 2 gives me 4. So that means after I take my y and I split it in 2, right, so each one of these is y over 2, right, y divided by 2, which is the same thing we see on that left side, right? And then that y divided by 2 is equal to 4. Well, then how much is my whole thing worth? How much is my whole y worth? Well, 4 plus 4 is 8. So I get that y is equal to 8. All right, well, now let's take a look at how we do that algebraically, because this is the way you're going to, that's the understanding of why this works. Now, here's what you're really going to be doing on the daily when you're trying to solve these. So we have our equation, y divided by 2 is equal to 4. We're going to do the same thing, right? We're starting on the side with the variable. So in this case, you see my variable there is y. So I'm starting on the left side of the equation. And I go, okay, well, starting over here, what operation is here? Well, I have y divided by 2. What's the inverse of dividing by 2? Well, multiplying by 2. What I do to one side, I have to do to the other, right? When I'm multiplying by 2 here, 2 is the same thing as 2 over 1, right? So you're not really going to have to do this each time, but we see when we're multiplying by 2, what we're really going to get is 2 divided by 2, which really just cancels out, and I'm left with just y on this left side of the equation. And now on the right side, I see I'm doing 4 times 2, which gives me 8. So I get that y equals 8, which is the same thing I got when I solved it with a tape diagram. All right, now I'm going to substitute this value back in just to double check, right? It was y divided by 2 equals 4, so I'm just going to plug in the 8. So I get 8 divided by 2 equals 4. Is that true? Well, 8 divided by 2 is 4. 4 equals 4. I'm good. All right, so I want to just retouch on this one, right? So when we're looking at solving an algebraic equation, we need to start on the side that contains the variable. We're going to identify what is on that side with the variable that I want to get rid of, right? Because my goal is to get it to be y equals or x equals or z equals. I want to get the variable on its own. So in order to do that, I have to use the inverse operation of whatever is being done to the variable. So I need to, if it's a division problem, I need to multiply. If it's a multiplication problem, I need to divide. If it's an addition problem, I need to subtract. And if it's a subtraction problem, I need to add. There's a lot here, but when you break it down and you go step by step, I think you're going to find that it's not that bad. All right, thank you very much for watching. I have a ton of confidence you're going to be able to do this on your own. Make sure you're doing the try this at the bottom and the review on the next page. Thanks, and have a great day, guys.